have you on Fascinating Frontiers, episode 117, coming to you on June 30th, 2026. The universe has been busy, let's get into it. NASA is launching a robot to lift its aging Swift telescope before atmospheric drag pulls it down. A robotic spacecraft will dock with the 22-year-old Neil Gehrels Swift Observatory and perform a controlled boost. The maneuver aims to extend the mission's life by countering gradual orbital decay. Swift continues to deliver ultraviolet, X-ray, and optical data on gamma-ray bursts and other transients. Launch is targeted for no earlier than 30 June at 10:17 p.m. UT+12. Engineers must execute the rendezvous with centimeter-level precision to avoid damaging the observatory. The effort demonstrates how commercial vehicles can now perform tasks once reserved for dedicated agency missions. Now shifting to a global effort marking a key anniversary in planetary defense. Asteroid Day marks the 118th anniversary of the 1908 Tunguska impact in Siberia. The annual UN-recognized event aligns with 8 other milestones tracked by ESA's Planetary Defense Office. Public education campaigns highlight how ground-based surveys and upcoming missions improve impact probability assessments. Observatories and societies worldwide are running events to share meteorite samples and orbital data. On a different note, Hubble has captured a sparkling view of a Milky Way globular cluster. The telescope recorded thousands to millions of stars gravitationally bound in the cluster nicknamed the chandelier. Such clusters serve as natural laboratories for studying stellar evolution across a wide range of masses and ages. The image reveals the cluster's compact core and extended halo against the galactic background. Hubble's ultraviolet and visible sensitivity highlights the hottest, brightest members that dominate the light output. Follow-up observations will refine proper motion measurements of individual stars. Next up, Europe's monthly roundup covers crew announcements and launch records. June highlights include the naming of the Artemis III crew and a record-setting Ariane 6 performance. Additional science updates cover ongoing missions and data releases from ESA spacecraft. The monthly roundup places these milestones in the context of Europe's broader exploration roadmap. Viewers can trace progress on lunar landing systems and heavy lift capabilities through the linked stories. Laboratory studies of ICES are the focus of a new NASA newsletter. Issue 3 examines laboratory studies of ICES relevant to comets, icy moons, and interstellar clouds. Researchers simulate temperature and radiation conditions to measure spectral signatures and chemical pathways. The newsletter includes interviews with scientists working on cold solar system objects and exoplanet atmospheres. Data from these experiments help interpret observations from telescopes and spacecraft spectrometers. In the morning sky, Neptune is now high enough for small telescopes. The ice giant lies near Saturn in Pisces and climbs to 30 degrees altitude by 3:30 a.m. local time. Observers can use the nearby brighter planets as guides to locate the distant world. No special equipment beyond binoculars is required under dark skies. The column notes Neptune's expected motion through the constellation over coming weeks. Chandra has detected repeated flaring from old supernova remnants. Dozens of remnants in a nearby galaxy show brightening instead of steady fading. In each case, a surviving companion star appears to feed material onto the compact object left by the original explosion. The interaction produces variable X-ray output over years rather than the expected monotonic decline. Chandra's repeated pointings captured the flickering behavior across multiple systems. Perseverance has examined organic molecules in ancient delta sediments on Mars. The rover studied sedimentary layers deposited by an ancient river that once fed a lake in Jezero crater. Organic molecules detected in the delta sediments formed under freshwater conditions billions of years ago. The findings strengthen the case that the site preserved potential biosignatures. Future sample return missions will allow Earth laboratories to perform more detailed analyses. A new preprint asks whether space-based artificial intelligence could resolve the Fermi paradox. Austrian researcher Sergei Ivliev models how widespread adoption of artificial intelligence might alter humanity's expansion into space. The work considers energy requirements and detectability of AI-driven civilizations. It suggests that rapid machine-driven growth could either suppress or accelerate interstellar colonization. The paper is available on Archive for further community discussion. A study has modeled whether ever larger rockets are always advantageous. Researchers examined launch economics and infrastructure demands for vehicles beyond current heavy lift classes. The analysis indicates that very large rockets can create bottlenecks in ground processing and range safety. Smaller, more frequent launches may prove more resilient for certain payload classes. The paper will inform architecture studies for future commercial and government fleets. New Horizons has recorded the solar winds slowing due to interstellar atoms. Southwest Research Institute scientists analyzed measurements taken as the spacecraft approaches the heliopause. Neutral atoms drifting in from interstellar space collide with the solar wind and gradually reduce its speed. The effect becomes measurable only in the outer heliosphere. The study appears in the Astrophysical Journal. If the sun were a basketball in downtown Toronto, the heliopause would sit roughly at the edge of the Greater Toronto Area. Yet the solar wind crossing that distance slows by tens of kilometers per second. Neutral atoms drifting in from interstellar space slip past the sun's magnetic shield, then collide with charged solar wind particles and steal momentum through charge exchange reactions. New Horizons recorded this gradual deceleration only after traveling beyond 30 astronomical units, where the density of interstellar neutrals finally becomes appreciable. The process unfolds over years rather than days, turning the outer heliosphere into a vast, low-friction drag zone. Exactly how the resulting pickup ions and secondary energetic neutral atoms redistribute energy across the boundary remains an open puzzle that future interstellar probes will need to map in 3 dimensions. NASA and the Small Business Administration have launched a joint investment initiative. The joint program will channel investment into small businesses supporting NASA's industrial base. Eligible companies can access capital for technologies ranging from propulsion components to ground systems. The initiative aims to reduce single-point failures in the current supplier network. Details on application timelines are available through the partner agencies. Seismic and thermal modeling suggest pockets of molten rock persist beneath the Martian crust. These systems could influence volcanic resurfacing and outgassing rates over geologic time. The findings draw on data from orbiters and landers that measured crustal thickness and heat flow. Further analysis will test whether any magma bodies remain mobile today. Researchers have modeled the orbital dynamics of giant space mirrors. Teams at University of Wisconsin-La Crosse and UC Berkeley examined how large reflective structures would maintain attitude and position. The study explores passive stability and potential signatures in reflected light. Results are posted as a preprint on AirEggs. Future work will assess detectability from Earth or future observatories. ESA's ExoMars Trace Gas Orbiter has scanned the Martian atmosphere for 8 years without confirmed methane detections. Instruments tuned specifically for the gas have produced a null result, despite earlier ground-based reports. The outcome tightens constraints on current or recent methane sources. Continued observations will monitor seasonal and spatial variability at higher sensitivity. Before we go, keep an eye on further seismic analysis that could confirm whether any magma bodies beneath Mars remain mobile today. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. SpaceX Daily, the daily companion for following SpaceX as a public company, from Starship to the stock ticker. Find every show free at naranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.